everyone, welcome back to my YouTube channel. This is Sangeeta BJ from Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering for some ECHA section. Today in this video we are going to discuss about the subject mathematics, and our topic is ordinary and partial differential equations. Particular contents we are going to discuss in this video are introduction, definition, types, applications, examples, and problems on ordinary and partial differential equations. Our first slide is introduction. An ordinary differential equation, which is also abbreviated as ODE, in mathematics is an equation which consists of one or more functions of one independent variable along with their derivatives. A differential equation is an equation that contains a function with one or more derivatives. But in the case of ordinary differential equation, the word ordinary is used for derivative of the functions for the single independent variable. In case of other types of differential equations, it is possible to have derivatives for functions more than one variable. The types of differential equations are partially differential equations, linear and non-linear differential equations, homogeneous and non-homogeneous differential equations. Let us move to the definition part. Definition. In mathematics, the term ordinary differential equations, also known as ODE, is an equation that contains only one independent variable and one or more of its derivatives with respect to the variable. In other words, the ODE is represented as the relation having one independent variable x, the real dependent variable y with some of its derivatives like y dash, y double dash, and so on y power n with respect to x. Order. The order of ordinary differential equations is defined to be the order of the highest derivative that occurs in the equation. The general form of nth order ODE is given as f of x, y dash, so on y power n equals 0. Note that y dash can be either dy by dx or dy by dt, and yn can be either dny by dxn or dny by dtn. An nth order ordinary differential equations is linear if it can be written in the form of a0 of x yn plus a1 of x yn minus 1 and so on an of x y equals r of x. The function aj of x 0 less than or equal to j less than or equal to n are called the coefficients of the linear equation. The equation is said to be homogeneous if r of x equals 0. If r of x is not equal to 0, it is said to be a non-homogeneous equation. Types. The ordinary differential equation is further classified into three types. They are autonomous ordinary differential equations, linear ordinary differential equations, and nonlinear ordinary differential equations. Firstly, autonomous ordinary differential equations. A differential equation which does not depend on the variable, say x, is known as an autonomous differential equation. Linear ordinary differential equations. If differential equations can be written as the linear combinations of the derivatives of y, then they are called linear ordinary differential equations. This can be further classified into two types, and they are homogeneous linear differential equations and non-homogeneous linear differential equations. And at last, non-linear ordinary differential equations. If the differential equations cannot be written in the form of linear combinations of the derivatives of y, then it is known as non-linear ordinary differential equation. Applications of ODE. Ordinary differential equations has remarkable applications, and it has the ability to predict the world around us. It is used in a variety of disciplines like biology, economics, physics, chemistry, and engineering. It helps to predict the exponential growth and decay, population and species growth. Some of the uses of ordinary differential equations are modeling the growth of diseases, describes the movement of electricity, describes the motion of the pendulum waves, used in Newton's second law of motion and law of cooling. Examples of ODE. Some of the examples of ordinary differential equations are as follows. y dash equals x square minus 1, dy by dx equals x plus y whole power 6, xy dash equals sin x, d square y by dx square plus 2 dy by dx plus 5y equals 0, where y of 0 is 0 and y dash of 0 equals 2, y double dash equals y dash plus x into e power x. So let us solve a problem for the clear picture of this concept. Find the solution to the ordinary differential equation y dash equals 2x plus 1. Let us go through the solution. The given equation is y dash equals 2x plus 1. So now integrate on both sides. Integration of y dash into dx equals integration of 2x plus 1 into dx. Y equals 2x square by 2 plus x plus c. Y equals x square plus x plus c, where c is an arbitrary constant. Thank you for watching. Please do like, share and subscribe to my YouTube channel.